So if this site is to act as a park as well as a museum, extensive shading is going to be required for the outdoor spaces. The microclimate data reveals that within the location, the outdoor spaces are not accommodating. The building itself needs to help create shade, motion, and flow across the site, setting up a connection from east to west to both help the park connect and develop across a series of complex social issues, rather than creating a barrier between them. So let's start with a quick sketch of some ideas. Go to my library, I've already loaded it in, and place that and move it in place. Double click to do a quick scale. Working edge to edge, again focusing really on the streets and making sure everything's correct. So I've got that located in. Let's drop its transparency down just a bit so we can see through it. This set of trees, we know that one of the things that's happening is this creek is being daylit, so it was in a concrete culvert. And so this tree line, or this tree grouping rather, that is on my base is going to go away, this particular proposal, as we're daylighting the creek. So all that's going to get dug up, so that topsoil is going to be completely changed and rearranged. So I want to keep those on my previous proposals, just in case we want to look at one where we're not daylighting the creek, which I don't think is going to happen, but let's do it anyway. So I'm going to move those to the library. So add to library. Then I can double click to move to my base and delete them. So at any point now I can come back and add those in from my library. Done. So we can look at this now as a quick sketch that shows creek location, building location is something longer, thinner, that runs an axis east to west. Because I'm a total geek, it lines up Chicago and LA, and edge to edge is 244.8 feet, which is a throwback to the 2,448 miles of Route 66. So if we turn on the massing, let's go to the proposal, and let's turn on buildings and generic, so we can start to get an idea of how that's going to work as an idea based off of the new information that we've started to work through. On this proposal, I can come in and start doing area with trees to start blocking in some of the new growth that we're showing. A little bit into the sidewalk there. Edit that in just a second. So to edit something like a perimeter, just a double click. I can drag that point back to where I want it and enter. And we'll leave those as fairly small for right now because, again, those are going to be new trees on the site. Something like this group, if I wanted to, I could add those in. You get the idea of where this is going. So at this point, I've already run the simulations on this new massing. So let's buzz through what changes we have. So I can go to my history panel. So this is sun hours. Again, not a lot of a difference on this. Again, looking at December 21st, other than this edge now, since it's elevated, spanning across the top, much more access to daylight hours. And then one of the requirements on site is this theater, so sort of a drive-in theater. So I'm leveraging this wall right here, and I'm not thinking of it as something we're going to bring cars onto the site, but you're going to drive, your picnic blankets onto the site and sit down and set up and watch a cool movie projected on the side of the building. So I actually kind of like that that's got a little bit of shade. We'll look at how that's going to play out in other simulations as well. If I move to my daylight potential, similar things. Again, there's not a lot of shade across the site. There are not a lot of tall buildings. So again, nothing earth-shatteringly different across this. Again, other than elevating that portion of the building, which I'm planning on being the actual museum portion. So it might not want a lot of daylight anyway. It depends on what is in that space. Wind. So if we look at the wind analysis, again, fewer dead spots around, especially at the entry and exit. So entry and exit here, entry and exit at this location, both of them would feed up and across and down. So a little bit happier with how that's playing out. If I look at the microclimate data, again, part of the goal of elevating the building was to create some shady spots across the site. So if I use my inspect tag now and look across at different locations along that sidewalk that we're putting in, as well as off. So in July at 4 o'clock, outside of the shade of the building, I'm approaching 100 degrees, but leveraging the shade of the building, I'm getting some much nicer areas in underneath. And that's a 15-degree difference, which is pretty remarkable. So again, I don't want to say it's justifying the idea of this elevated building, but it's certainly leveraging the building more as a shading device than the other solution was. In fact, let's do a quick comparison. So we can look at the comparison tool as something where we can scroll back to our previous projects. So let's go back to base 1. And we can look at latest version and drag and drop that into place. In terms of, oh, where did my proposal go? Base 1, latest version, microclimate. So compare allows us to look at the two different versions and understand how much we are getting on the site in terms of different locations and what they are doing. So 86 degrees on one, 100 degrees on the other. And then this compare tool allows us to see two pieces sort of mirrored moving around at the same time in terms of what we are getting with that data. So let's close compare mode and go back to the site design. Noise. Again, if we look at the history on this and pull up what we run, we're pulling the building, especially here on this east side where we had the most intrusive noise. We're pulling that entry a little bit further away and creating these quieter moments deep further into the site, sort of those prime areas of the park. Solar panels. By a longer, thinner design, we actually have 2,000 square feet more of coverage, which gives us more total output. We're getting closer to 100% of the building's energy consumption, which was 140 kilowatts per square foot. We're much, much closer to that now, only 10 kilowatts per square foot off, assuming a 60% coverage. Let's go back to our embodied carbon as the last piece. So our last piece then is looking at carbon, embodied carbon, and again, simplifying this down, similar volume, don't have a really good way of replicating that bridge, so we're just looking at the area of it. So when we switch to carbon, we are again going to do the run analysis, scroll down, and we're going to look at a couple of changes that we've made in terms of how it's going to work. So if I select my building, notice I've set this to commercial. My envelope is still the steel panels, and I've changed the structure to mass timber. The results on that are 360 kilograms of CO2 per square meter, which changes to 35 kilograms per square foot, which is down from 53 kilograms per square foot. But knowing that this sort of bridge thing that I'd really like to do might not be too feasible with heavy timbers, even though like I'm, on the massing model, I'm starting to play with what would columns look like across here? How could something like that come together? But knowing that it's maybe not probable, we can certainly come in and select the building and very quickly change this from mass timber to a composite steel frame. Close that, rerun the analysis, and we'll notice that it sends us right back to almost the exact numbers that we were before with 53 kilograms per square foot. So the idea here, though, is that we can continue to look at variables in terms of carbon performance on what could work and how we can improve that building performance given those basic variables on our site.